Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. Today's practice problem, when not to create an object, we're going to be creating a MathHelper static class. Write a MathHelper class with welcome helper messages, an area of a circle method, and Fahrenheit to Celsius method. Do not create any objects. Let's jump right in. Just as previous videos, I've pulled in the description from the question just so I have a really good view of everything I need in order to solve this problem. Now, the first thing it's telling me to do is write that MathHelper class. So I'm going to go ahead and do that on the other side of my page here. Public class MathHelper. And I'll save it as a MathHelper class. Now, this looks very similar so far to my main method. They both just have the words public class and then the name of the class. And that's incredibly intentional. We're going to leave it at that for just a second. I want you to think about a static class or a class level class a bit like a calculator. Every time we do an addition or a subtraction, every time you go check your work in a math assignment, do you buy a new calculator? Do you use a new calculator? Hopefully your answer is a no. You use the same calculator with lots of different inputs. That's what we're talking about here. A static class such as our MathHelper, is really just a class that has a bunch of methods grouped together with similar responsibilities. Just like a calculator has lots of functions, arithmetic functions grouped together on it, that we can use to solve problems related to math. That's what we're doing here. So when we create a MathHelper class, we can choose what is public facing and what is going to be private, just as we'd expect in a calculator. We can't necessarily see the insides of our calculator. We can't see the, adders and multiplexers and transistors, and my hardware is not great, so that's where it ends. We can't see all the electronic bits, but we're given this, the buttons, the interface that we can interact with that allows us to type in the numbers and tell us the math that we want to do. So let's set this up very similarly. Let's start with a private static final welcome message, since it does say we need some kind of welcome message. Now, normally we probably wouldn't have this in a class, but I did want to show off how we do final static variables, which is why I sort of chose to do it for this video here. So we can go ahead and make it, since it's a static final message, we can go ahead and set up here what we want the welcome message to be. Welcome to the MathHelper class. There we go. All right. And you'll notice that I do set the equals up here at the same time as my declaration, which you haven't seen me do before if you've watched my other videos. And that's because if we were setting instance variables, instance fields, we'd need to do it inside of a constructor. But here we don't really have a constructor. We have no reason for a constructor. Now, in theory, somebody might be able to still make a MathHelper object, and there are ways to stop that, but that's outside the scope of this video. So don't worry too much about that for this one. Let's just start by being able to actually print out our welcome message. Let's make a button on our calculator. So a public facing method, public static void print welcome message. And all it's going to do is print out our welcome message, and that's it. Now, since this is a static variable and this is a static method, we can just use it directly. It may be private, but since we are inside the MathHelper class, we don't need to reference it by MathHelper. We have direct access to it in here. If we come over to our main method over here, we can now actually try to print out our welcome message. In order to do this, we say MathHelper dot print welcome message. So what we're doing is we're saying go over to the MathHelper class and find, because we're calling it on the class, the static method print welcome message. It will find the static method print welcome message, and it will run this line of code. As usual, we should test this, make sure that it works as we're expecting. All right, let's compile, make sure that everything works as we'd expect. No errors, that's great. And then we can run our main method. Now, even though both of these do have static methods in it, whichever one I type here, that's the one that has my main method in it. That's where my running should start. And what we can see happens is it does indeed print out welcome to the MathHelper class. So this first step is done. Let's move on to the next step, which is the area of a circle. Now, your calculators at home probably don't have a calculate area of a circle method. You have to do it directly, but we are sort of creating a MathHelper, right? It's a MathHelper calculator. So we are going to make a new method over here, public. Let me just move this over. Public static, whoops, probably double area of a circle. Now, in order to calculate the area of a circle, if you don't know your formulas, we're going to need the radius, and it's going to be pi times the radius squared. Like the radius is squared, so the diameter. So we're going to take in a radius in order to solve this problem, and I'll do this in 2 steps. My first step will be to square my radius, square radius to get my diameter. I'll go ahead and leave that note. After that, I can multiply my diameter by pi to get the area. And then I can return the area out of this method. Okay, so with that, I can make my return area, make that value just equal 0. There's nothing that suggests that there's anything that could be a problem here. Now, of course, you can't really have a negative radius. So I could do some kind of check here if I wanted. That says no negative radii allowed. If you were doing something maybe a bit more fancy with like polar coordinates or orientations and directions, maybe you'd have a negative radius, I suppose, but we're talking pretty standard here. We're not doing anything that fancy for this. Okay, so we're now saying if our radius is less than 0, we're not allowing it. Otherwise, we can come right here. All right, what did we say we're going to do? The first thing we said we were going to do is square our radius to get our diameter. Now, there are 2 ways to do this. We can do double diameter is equal to radius, times radius. And this counts, right? This is one way of getting our diameter because we're doing a radius times a radius. That's the same thing as radius squared. However, I do want to sort of take this as an opportunity to use a math function. I'm going to use math.pow, pow for power. I can say radius 2, and this will basically take radius squared. So whatever number you put there allows you to square it. The reason why I want to do this is because we'll notice that we're using the capital M math class, meaning this pow method is a static method inside the math class. I think it's really important that we take an opportunity to pause and realize that that's what this is. We know it's a method because it has these brackets here, right? Round brackets mean method. And we know that it's a static class level method because we're not calling it on a math object, we're calling it on the math class. Once we've done that, we can now get our area. How do we get our area? We are going to take our diameter and we're going to multiply it by pi. Now, if we multiply it by pi, 3.14, we can get an answer. But that's not a particularly precise reading of pi, to just say 3.14. Depending on what we're doing, that may be good enough. But for right now, we're going to assume we want it to be more precise. So we're going to go back in and use math.pi, which is a public-facing variable, or I guess constant, in the math class. So this is a math static constant. It's the same as writing our welcome message up at the top here, except instead of private static final string, it would say public static final double. So that's what this is. It's a double variable that lists more digits of pi, and it is a variable or a constant. It's a property of the math class, which I can tell because it does not have the round brackets on it. Once I've done that, I'm onto my third note here, which says to return the area. I can go ahead and I can test this out over here. Double area is equal to math MathHelper dot area of a circle. Now, simply the area of a circle of size 1 will allow me to make sure that my calculation worked as expected, because I don't have a calculator beside me and I want to make sure that my math actually worked. I can do an area of a circle of size 1 and I should get 3.14. I'll also, with whatever other decimals, I'll also do after a radius of 2, because then we can just take 2 squared, getting 4 times 3.14, etc. And we'll get our answer there as well. So I'm just picking some low-level radii, yeah, that I know that I can sort of do in my head to make sure I'm getting the right answer and to double check my math here. So I'll go ahead and print out whatever I got, just like this. I'll go ahead and recompile my code at the bottom here, run it, and we can see I did get my expected number. If I put a 2 in here instead, I should get 2 squared as my radius is 2 squared for my radius will give me a diameter of 4, and then 4 times pi will give me, I don't know, 12 something. There we go. So I can see that I'm getting what I'm expecting. My math here is sound. I'd like to draw your attention to one more thing before we move on to the final part, Fahrenheit to Celsius. I'd like to draw your attention to system.out.println. Capital S system is a class. This out here has no round brackets on it. It tells us that it's actually a static variable in our system class. So rather than private static final string, as we have in our MathHelper, system has one that says public static, and it's might be final. I'm not sure. I don't think it is. Print stream out. So this is actually a variable inside system. And then this variable has a instance method, because it's a variable, print line. So system.out is actually a variable, a static variable inside system. And then out.println is actually println is an instance method on the out variable. Just something interesting to point out to you. All right, let's go ahead and make one more method over here in my MathHelper, my Fahrenheit to Celsius. Public static double Fahrenheit to Celsius. I'm going to need some kind of number coming in Fahrenheit. How do we do this math? We take our Fahrenheit minus 32, and then we'll multiply it by 5 divided by 9. That is the formula that we use. It's a pretty standard formula. It makes sense for these to sort of stay quote unquote magic numbers in here, just because there's not really anything else to say here. Now, we can have a negative or positive value when it comes to a Fahrenheit input value. So there isn't really any error checking that I feel like I need to do here. I can just go ahead and write it all in one line, F minus 32 times this division. Now, I love a good set of brackets. Thanks to order of operations, you may or may not need brackets sometimes, but I always find that if you're ever unsure, brackets will make sure that it's nice and clear to whoever comes to read your code later. That's really all there is to this method, so we can go ahead and we can test it. Now, beforehand, I double checked that I had some test values. 10 Fahrenheit should be like negative 12-ish Celsius. I also know that 32 Fahrenheit is 0 Celsius. So those two values I can check here. And I can actually just do all this in one print line, MathHelper dot Fahrenheit to Celsius. And I can start with this one here. We'll go ahead and recompile. And we've got an error here, MathHelper. Oh, did I spell something wrong? I did. I spelt it wrong. Well, I spelt it wrong originally. There we go. We'll just fix both of those. There we go. Let's clear this out of the way and recompile. No errors. That's great. We can run it. And we found a very interesting error. I should cut this out, but I won't. You'll notice that I got -0, which is incredibly unexpected. Why did I get -0? Well, I took 10 and I subtracted it from 32. I should have gotten -12 there. And then I should have been able to multiply 5 divided by 9. And 5 divided by 9 is, I don't know, some decimal value. So I should have gotten -12 times some decimal value. That's not what I got here. And that is so confusing. Now, if you took 1010, this is something that should jump out at you, or at least I hope it will. If you didn't, this is a great opportunity to learn. When you do an integer divided by an integer, you're going to get an integer out of it. So on line 21 in my MathHelper class, when I did 5 divided by 9, instead of getting 0 point something or another, I got the integer value, which was just 0. And so then I did -12 10 minus 32 times 0, which is why I got a 0 answer. If I want to get a double value out of this, I need to make some changes here. Now this 10 is already in double form because, whoops, we look right here and it's double F. So by default, this right here already gave us a double value. 10.0 minus 32 gave us -12.0. This right here is the problem. All I need to do is turn one of these two numbers into a decimal, and now I will get this coming out as a double value. Little trick there for you. And now we can see I'm getting the actual value that I expected, which was -12.222, etc. I can do one more test here now with, instead of 10, doing 32. This time I should actually get 0 out. Recompile. And there we go. I got the value 0 out of my Fahrenheit to Celsius calculator. And that's all there is to this idea of a class that has static functionality, static methods, and static variables. That's it. And now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.